Now we have the next question which is related to dihalogen compounds. The question is, vicinal and geminal dihalides can be distinguished by aqueous KOH, alcoholic KOH, zinc dust, both A and B. Sometimes in the multiple choice questions, we need to go for elimination process. Here we have the reaction with zinc dust, which is a characteristic reaction of phenols. But here we have vicinal and geminal dihalides, they cannot react with this zinc dust, so option C is ruled out. But we are left with three options now: aqueous KOH, alcoholic KOH, both A and B. Let us try the reaction of vicinal and geminal dihalides with aqueous KOH to make a distinction between them. If you take an example of vicinal dihalide, 1,2-dichloroethane and geminal dihalide, 1,1-dichloroethane. Since these are halogen derivatives, they can undergo reaction with aqueous KOH, which is a nucleophilic substitution reaction. With aqueous KOH, we get here a glycol wherein Cl is replaced by OH, that is a nucleophilic substitution. Same thing happens here also. Here we get CH3 CHOH twice. But the problem with this is the two OH groups are attached to the same carbon atom. If the two OH groups are attached to the same carbon atom, this becomes unstable and this decomposes to give CH3 CHO by the elimination of water. So, with aqueous KOH, vicinal dihalide gives glycol, while the geminal dihalide gives aldehyde. One gives glycol and the other one gives aldehyde. On the other hand, if you take alcoholic KOH, this is also one of the characteristic reactions of haloalkanes and even halogen derivatives. If you take this alcoholic KOH, if you heat this with alcoholic KOH, this Cl and this H first forms alkynyl halide. Further, this H and this Cl forms alkyne. So, with alcoholic KOH, vicinal dihalide gives alkyne, and even this one, first with KOH it gives alkynyl halide again. This H and this Cl is removed in the first step. Then in the second step again one more H and this Cl is removed. Again we get alkyne. Both give alkynes with alcoholic KOH. But with aqueous KOH, one gives glycol and the other one gives aldehyde. So therefore, aqueous KOH can be used to distinguish vicinal and geminal dihalides, but not alcoholic KOH. So automatically these two options get ruled out. The correct option to make distinction between vicinal and geminal dihalides is aqueous KOH. Now move on to the next question. Which of the following statements is true? A. Allyl chloride is more reactive than vinyl chloride. B. Vinyl chloride is as reactive as allyl chloride. Vinyl chloride is more reactive than allyl chloride. Both of them are more reactive than chlorobenzene. In such questions, simply if we look at the options, we get confused and it's very difficult to select the correct option. So therefore, in such questions, we should find the basic of this reactivity order. We had looked into the different types of alkyl halides, different types of halogen derivatives. I had told you that benzyl chloride is R-alkyl halide, ethyl bromide is alkyl halide, vinyl chloride is alkenyl halide, 3-chloropropene is allyl halide, and chlorobenzene is aryl halide. We should remember the reactivity order of these different types of halogen derivatives. The reactivity order is R-alkyl halide is more reactive than alkyl halide. Alkyl halide is more reactive than allyl halide. Allyl halide is more reactive than alkenyl halide. Alkenyl halide is more reactive than haloarene. The example for this is benzyl chloride, this is ethyl chloride, this is allyl chloride, this is vinyl chloride, and this is chlorobenzene. If you remember this order, now you will get the answer for this question. See the first option, allyl chloride is more reactive than vinyl chloride. Allyl chloride is more reactive than alkenyl chloride or vinyl chloride. So therefore, the correct option for this is A. While rest of the three options are not in this order. So the correct option is A. In the next question, we have been given a series of reactions. In this series, first we have CH3, CH2, CH2Br reacting with aqueous NaOH giving X. This on heating with alumina gives Y. Y reacts with HOCl to give Z. In this series, we need to identify Z, the end product in the reaction. The end product in the reaction can be predicted when we write this series completely. So here starting material is CH3, CH2, CH2Br. Look at the starting material. It's a alkyl halide. It's a monohalosine derivative of propane. So, this undergoes hydrolysis with aqueous NaOH to give corresponding alcohol. So, therefore, we get CH3, CH2, CH2OH. So, X is the alcohol, Br is replaced by OH in this X, and this alcohol is further heated with alumina. This heating with alumina is a dehydration reaction. We know that alcohols on dehydration yield corresponding alkenes. So, therefore, the product here is CH3, CH double bond CH2. So, dehydration of this alcohol gives alkene, and we know that alkenes readily undergo addition reaction with HOCl. So, the end product when this reacts with HOCl must be CH3, CH, OH, CH2Cl. This addition takes place in accordance with Markovnikov's rule. So, this alkene on addition reaction with HOCl in accordance with Markovnikov's rule forms CH3, CHOH, CH2Cl. So, the product formed here is CH3, CHOH, CH2Cl. So, this end product we have in the given options as the option B. So, therefore, option B is a correct answer for this series of reactions. So, this is how we need to select correct answer for such questions. So, B is a correct option. Let me discuss the next question. The question goes like this. In the following reaction, C6H5CH2Br, the first step is it's reacting with magnesium in ether. In the second step, we have acid hydrolysis. We get the product X, and we need to identify this product X. The options given are C6H5CH2 OCH2C6H5, option B C6H5CH2OH, option C C6H5CH3, option D C6H5CH2CH2C6H5. To get this X, look at the first step that the reaction is involving. Whenever the halosine derivatives react with magnesium metal in ether, they form Grignard reagents. And we know that Grignard reagents on hydrolysis form the corresponding hydrocarbons. On the basis of this concept, we can write the product of this reaction. So, first we have C6H5CH2Br benzyl bromide reacting with magnesium in ether, forming C6H5CH2 MgBr, the benzyl magnesium bromide, which is a Grignard reagent. This on hydrolysis, this undergoes hydrolysis at this CH2MgBr. So, here we have the hydrolysis of this Grignard reagent yielding the product C6H5CH3 as the product. So, this product C6H5CH3 toluene is in option C. Therefore, the correct option, the X in this is C6H5CH3, that is C. Let us see the beauty of the next question. The question is, the structure of the major product formed in the following reaction is. In the reaction here, this dihalogen derivative reacts with sodium cyanide in DMF solvent, and the product formed in this reaction is to be predicted. There is a lot of difference in these two halogen atoms attached to this aromatic ring. Look at this halogen atom. This is the halogen atom bonded to sp3 hybridized carbon atom. Well, this is the halogen atom bonded to sp2 hybridized carbon. Just now in the synopsis we had seen that haloarenes are less reactive than haloalkanes or R-alkyl halides, because in haloarenes, halogen atom is attached to sp2 hybridized carbon or double bonded carbon. So, therefore, the halogen atom attached to the sp2 hybridized carbon is less reactive. So, we have one active halogen here and the other inactive halogen. Out of these two halogens, this is the halogen atom undergoing nucleophilic substitution with sodium cyanide. When there is a nucleophilic substitution with sodium cyanide, this Cl is replaced by Cn minus, and this part remains as it is. So, the major product formed here has Cn in place of Cl and I remains as it is. That we have to search in the given options. So, in the option A, as it is we have it here. In option B, so Cl, the most reactive halogen atom, has remained as it is. So, therefore, this is not a suitable option. In option C, so we have the suitable replacement, but this is changed. So, this is also not suitable option. So, option D, wherein Cl is replaced by Cn and I remains as it is a major product. Therefore, the correct option is option D. So, now we will come to the question related to chlorobenzene. Chlorobenzene, on heating with aqueous ammonia under pressure in the presence of cuprous oxide, gives benzamide, nitrobenzene, aniline, chloraminobenzene. We know that chlorine in chlorobenzene is less reactive. Chlorine in chlorobenzene is less reactive due to the double bond character of the chlorine in chlorobenzene. This chlorine in chlorobenzene cannot be replaced under normal conditions. So, it can be replaced by the nucleophiles under drastic conditions. So, we have the drastic conditions here, use of ammonia under pressure, and also we have the presence of the catalyst. So, when chlorobenzene is heated with ammonia in presence of cuprous oxide catalyst at 200 degrees Celsius under 60 atmospheric pressure, we have nucleophilic substitution of chlorobenzene. So, Cl is replaced by NH2. So, chlorobenzene gets converted into aniline under these drastic conditions. So, the correct option for this question is option C, aniline.